Okay, from 4.4, we will do a couple questions. Please have your book with you. I will do example 1, number 2 first. Number 2. You will see that in Calculus 1 later on, this type of question show up again in chapter 6 or chapter 5 toward the end of your Calculus 1, but you need to do a lot of word problems. I think chapter 4 and chapter 3 and chapter 5 with the new textbook they have. Okay, let's see number 2 in 4.4. A rectangle is inscribed in a circle of diameter 12 inches. So let's say I have a circle, and the diameter of that circle is 12 inches. So this is 12 inches. And then I want to inscribe a rectangle in there. I inscribe a rectangle in there. Now, what we mean by inscribe a rectangle is to put the rectangle inside such that the corner of the rectangle are exactly on the circle. That's what we mean by inscribing. Okay. Now then, the question is, express the perimeter of the rectangle as a function of its width x. Suppose this is the length and this is the width. Now, according to the passage in question number 2, they will call the width x. Now, the question is, what is the length? Is it okay? Now, we know that the diameter of this circle is what? The diameter of this circle is 12. Is it right? Okay.
Yeah.
So I can draw from this corner here to this corner here a line, and this line must be the diameter also. Is it right?
Jeffrey just texted me that the password is not working.
Tell him to use lowercase l instead of capital I.
Use lowercase l.
So the 5th character is lowercase l.
The 5th character I.
No, the 5th character is lowercase l. Okay, now let me continue. So if I bring out that triangle, oops, no, not this triangle, sorry, not this triangle. I want the right triangle. But they don't have it. Okay, then I use this. This guy here. Okay, now suppose this is the width, which is x. This is the length. This is 12. Okay, now part A, the question is, let's see my chat. Oh, I see. So you have to type it in, huh? Yeah, when I type it in, I type it twice originally. The first one I use capital I, and the second one I use lowercase l. It appears very, very similar. I mean, it looks the same for me. So that's why I get confused too at the beginning. I hope Jeffrey can get in. Jeffrey, are you here? Not yet.
No, he's not here yet.
Okay, but let me go on. Okay,
Yeah.
so part A, the question is express the perimeter as a function of its width. Now the perimeter is twice the length plus twice the width. But I need to express this length first in terms of x. My w will be x, right? Okay, so if I go back, then this is 2 times something plus 2x. But what is my length? Now, my length I will use Pythagorean theorem. I will use Pythagorean theorem. Now, by Pythagorean theorem, what is this? In terms of x. So the length squared plus x squared equals root 12 squared. Is it right? So L squared, the length being squared, is 144 minus x squared. So the length is supposed to be plus minus of square root of 144 plus x squared. Now, however, we know this length is supposed to be positive. It's a length, cannot be a negative length, right? So I will just take the positive branch instead of the negative branch. Are you with me? Now, that's the L that I will replace here. Okay, so if I go back to my perimeter, okay, that will be 2 times square root of 144 minus x squared plus 2x. Now, to be more precise, because the question wanted us to write the perimeter as a function of x, we're supposed to write p parentheses x. That's what we're supposed to do. Okay, that will be 2 times square root of 144 minus x squared plus 2x. Okay, now let me ask you to read part B. Okay, let's see part B. Part B, express the area of the rectangle as the function of its width x. So the area will be length times width. Therefore, the area equals to, the length is square root of 144 minus x squared multiplied by x. Right? This rectangle here. We're talking about this rectangle. The area of this rectangle. Right? But for me to find the length in terms of the width, I need to look at the right triangle there. Okay, now then if I go back, because I need to write it as a function of x, then I have ax equals to, let me write this x at the front, x square root of 144 minus x squared. That's for question number 2. Now, I hope you follow me in writing. Now let me go on with the next question, question number 4. Some of you moving too much and create a lot of noises. Do you mind to mute your microphone? Okay, number 4. We have a picture there. Let me scroll this down so that I have enough space for number 4. Number 4, I have a coordinate system. And then I have a curve. Let's say it looks like this.
Which page is it?
This is number 4.
What page?
Section 4.4. And the equation of the point P, a point P Pxy lies on the curve y equals to square root of x, as shown in the figure. And then express the area of the shaded triangle as a function of x. What triangle? This triangle. This triangle. Let me change that to blue. So we refer to this triangle here. Yeah, these are the things that I cannot do in class lecture. You know, you need to have your book, right? And then we each look at the book. Right now, I can then kind of like draw it a bit here, and hopefully you can get a better idea. So if I go back, this is my x here, and what is the height here? This is supposed to be the y, right? But what is y equals to?
Root x.
Square root of x. Now, therefore, in part A, express the area of the shaded triangle as a function of x. So the area equals to 1/2 base times height, right? But what is the base? What is
X.
this? The base is x, that's right. How about the height?
Square root of x.
Square root of x. Now we need to write this as a function of x, so I need to write a x using function notation. Okay, while part B express the perimeter of the shaded triangle in terms of x. The perimeter will be the base plus the height plus the hypotenuse. Is it right? What is the base again?
Okay.
How about the height?
Of x.
Square root of x. Now then, for the hypotenuse, we don't have yet. Right? We don't have that yet. But can you apply Pythagorean theorem?
Yes.
Yes.
You apply Pythagorean theorem here. So the hypotenuse will be square root of
X squared plus
x squared plus
square root of x.
x squared plus square root of
Square
x
root of
being
x.
squared, right?
Yes.
Yeah, but that will be square root of x squared plus x.
X.
So that's what I put here. That's square root of x squared plus x. Now, that's our perimeter function. Okay, again, in calculus, you will go on from here. For example, one of the questions maybe is like, oh, find the x that give us the largest triangle, or find the x that give us the largest perimeter, like that. Okay, what we do right now is just to set up the function. Depends on what they want to see later on. That's for number 4. Number 6. Is number 6 a good question? Okay, that's a good question. We need to remember something. Number 6, the volume of a right circular cylinder is 12 pi inch cube. So suppose I have a cylinder. Suppose I have a cylinder, a right cylinder means it's perpendicular to the base. Let's say I have a right cylinder, okay, and then the volume is 12 pi inches cube. Now, suppose do you remember the volume of a cylinder? The volume of a cylinder is the area of the base. Let's call that R.
Pi squared times h.
That's equals to the area of the base pi r squared, that's the area of a circle, right? Multiplied by the height. Multiplied by the height. Let's say this is the height. Now the question is, express the height as a function of the radius. Express the height, we need to solve for the height. We need to solve for this, the height. Isolate the height such that the radius is on the other side. So I have 12 pi, let me ignore the inches cubed for now, equals to pi r squared height. I can divide by pi such that the height is 12 over r squared. Okay, now that's for part A. Now, they want us to write this height as a function of, in terms of r squared, so I need to write that as HR. This is 12 over r squared. Now, then, in part B, express the total surface area as a function of the radius. So part B, find the surface area. But what is the formula for surface area of rectangular, right circular cylinder? Now notice that this right circular cylinder consists of three parts. The first one is the area on the top, the circle on the top. Are you with me?
Yeah.
Which is the same area to the circle at the bottom. See, right? So this surface area will be 2 times the area of the circle plus the area of the lateral area. The lateral area. The lateral area. Which if let me ask you to imagine. Imagine if I cut, maybe I cut this side here, I cut it here. I cut this cylinder, and then I open it. What do you see?
The inside.
You will see a what? You will see a rectangle. Okay, you will see a rectangle. Now, whose width is the same edge here. It will be the same edge here. But this part here, the length of that rectangle will be equals to the what?
The circumference.
Circumference of the circle.
Yeah.
Okay, which is equals to 2 pi r. So the area of this rectangle will be 2 pi r h. Is it right? Now let me bring it here. 2 times area of the circle plus area of the rectangle. That's the total surface area. Then I come back. This is 2 times the area of the circle is pi r squared plus area of the rectangle is 2 pi r h. That's the surface area. Now they want the surface area in terms of, as a function of the radius. Okay, so because I need to write it as a function of radius, any variable that is not radius, I need to substitute, right? I can rewrite that h now in terms of radius. So now this is equal to 2 pi r squared plus 2 pi r times
over r squared.
12 over r squared. That's right. Oh, welcome, Jeffrey. Finally, you're here.
My computer was messed up. I don't know. I was trying to log on since like 4 o'clock. Sorry.
I don't think it's your computer. I think it's the password that's kind of strange.
Oh.
The password is like the capital I and lowercase l looks the same. So I myself didn't know what's that. Okay, over 24 pi over r. Now this is r surface area as a function of the radius. Okay, now here's the note. In Calc 1, in Calculus 1, they will ask you right away, the area in terms of the radius without asking you to write the height in terms of the radius. Okay, but at that time they assume you know that you need to find part A first before you do part B. That's what makes this part here quite difficult when you go to Calculus 1. As I know, some instructor from the little talk we usually have in my office, some instructor actually skip this part because they say, oh, it's too hard to teach. Well, because it is too hard to teach, I need to teach that now because it's harder to teach later on. You see what I mean? Now, with this said that people think that this section is hard to teach, it means when you study this on your own, if you find this to be hard, it means you are. If you study this section and you find this to be hard, it means you are normal. Okay? The only time you will find this section to be easy is when you don't do anything. Okay, now that's for number 6. Let's see number 8. I think number 8 is another interesting question. Number 8 is an interesting question. The product of two numbers is 16. The product of two numbers is 16. Now, this time they don't give us any graph. They don't give us geometry. Let's define those two numbers and let x and y be, let x and y be those numbers. The first sentence says that the product is 16. The product is 16. X times y equals to 16. Express the sum of the squares of those the two numbers as a function of a single variable. So what we want is we want to express the sum of the squares of those two numbers. Again, one of you make a lot of noise. Do you mind to turn off your, to mute your microphone? Yeah, thank you. We want to express x squared plus y squared as a function of only one variable. So I can express this expression here in terms of x or in terms of y. Let me do it in terms of x. So it means I need to substitute this y, right? I need to substitute that y. So that will be x squared plus something squared. Now, what is that y in terms of x? I look back to the equation that I already have. If x times y equals to 16, then y equals to what?
X minus 16.
Huh?
16
16 by x.
x.
16 by
divided
x.
by x.
Oh, sorry.
Yeah, divided by x, right? Okay, now
Right.
that's what I will put here, 16 over x quantity squared. Okay, that's what I use here. Now then, I simplify a bit further. This is x squared plus 196. No, 256, my bad. That will be 256 over x squared. Okay, that's the sum of the squares of two numbers as a function of a single variable. And the function of the single variable we're looking for this number 8 is this guy. Okay, now then somewhere in calculus 1, then they will ask you find the x that give you the smallest sum of squares, let's say. Now, that's something we cannot answer right now. That's for number 8. Number 12. In fact, number 12 is so important, I would like you to memorize the result we have from this number 12. Number 12. Let 2s denote the length of the side of an equilateral triangle. So suppose I have an equilateral triangle. Equilateral triangle. And the length of the sides are 2s, which means each side, it's equilateral triangle means each side has the same length. Okay, express the height of the triangle as a function of s. We want to express the height of this triangle as a function of as a function of s. Okay, so I need to find what's the height here. Okay, of course, because that's the height, it must be perpendicular here, right? Okay, but if that's the perpendicular bisector, then what will be the length here? What will be the length from here to here?
S.
That will be s, that's right. Now then, you can apply Pythagorean Theorem on this right triangle here. Right? Okay, so s squared plus h squared equals to 2s in squared. Now let me ask you to work it out to find what is h. I give you 1 minute now, 30 seconds. S squared plus h squared equals to 4s squared. H squared equals to 3s squared. So h is the square root of that, square root of 3s squared, which simplifies to be s square root of 3. Okay, now that's for part A. So h as a function of s is s square root of 3. Now we will see this right triangle a lot later on when we deal with trigonometry. Nona, do you mind to mute your microphone? Nuna, yeah, thank you. Yeah, this is a 30-60 degrees triangle. Part B. Express the area of the triangle as a function of S. The area of the triangle will be 1/2 times base times height. Now, which is 1/2. What is the base?
S.
2S.
2S.
No.
It refers to the original equilateral triangle.
Oh yeah, 2x.
Okay, 2S, and then the height is
No.
S square root of 3. Okay, so when I put them together, let me write that as a function of S right away. The 1/2 and 2 cancels. We have S squared square root of 3. Now part C. Now once we can set it up, then part C, use the function you found in part A to determine the type of equilateral triangle if each side of which 8 centimeter long. So if each side is 8 centimeter long, but each side is denoted as 2S. Is it right? So what is the S?
2S.
So what is the S? That would be 4 centimeter. Okay. Now then, what is the height? Then the height will be 4 square root of 3 centimeter. Part D. Use the function we found in part B to determine the area of an equilateral triangle if each side is 5 inches long. So if each side is 5 inches long, which is 2S, what is S?
Uh,
5/2.
5 over 2. Or you can say that's 2.5, right? 2.5 inches. Therefore, the area of the triangle will be 2.5 square root of 3.
I have a question.
Mm-hmm.
Why is it not 10?
Because they say the side is 5.
Yeah, and we have 2s.
We have to what?
2s.
2S is for the whole side. See, 2S is for the whole side,
Oh, okay.
right?
Yeah.
That's why then I divide by 2 to get the actual S. And once we get the S, then we use that S for the formula. So this is 6.25 square root of 3 square inches.
Oh, okay.
Okay?
Yeah, got it. Thank you.
Mm-hmm. So this question number 12 actually help us doing the following. Suppose they don't give us part A, they don't give us part B, and then they suddenly ask, okay, then if you have a side 8 centimeters, how to find the height? You know, so you basically do what you did in part A, but you plug in numbers. Likewise, if they ask you part D right away, you have an equilateral triangle, the side is 5. What is the area? Now, then you need to find the height first in terms of S, and then do part B. Okay. The reason I say that this is an important for your calculus 1 is mainly because you need to know how to set it up, and do not expect an instant works. It's like you do a little thing, you get the answer right away. Nah, not even in my class, you know that. That's number 12. Let me ask you to choose some problems between number 14 to number 20, maybe.
Into
Number what?
18.
Number 18. Let's see, number 18. The base of a rectangle lies on x-axis, while, okay, so let me get the coordinate system. Okay, and then the base of a rectangle lies on x-axis, while the upper two vertices lie on the parabola y equals to 10x squared. I need to draw the parabola first. Let me draw the parabola. 10 minus x squared. So approximately it looks like this. This is y equals to 10 minus x squared. The vertex here is, what is the vertex here?
10, 0.
0, 10 to be more precise.
0, sorry.
Okay, now how about this guy?
5, 0,
No, it won't be.
10, 0.
No. Square root of 10,
Square root
comma
of 10.
0.
Square root of 10. Yeah.
And this guy is negative square root of 10, comma 0. You solve for the 0. So you set x, the y equals to 0,
Ah, yeah.
right?
Yeah.
Okay, and then you solve for the x. Now, we will put the rectangle in there such that the base coincide with the x-axis. Okay, approximately like this maybe, right? Okay, and then suppose that the coordinates of the upper right vertex rectangle are x comma y. So I will call this vertex here coordinate x comma y. Now express the area of the triangle as function of x. So we are interested in finding what is the area of the rectangle, not triangle, sorry, rectangle as a function of x. Okay, let's start. If this is xy, then I need to know what's the base, right? What is the base? What is this first? What is this?
That's x.
That's x, that's right. This is x. This is x.
2x.
So the base is 2x. How about the height?
Just y.
The height is y. The height is y. So the area of the rectangle is equals to the base times height, which is 2x times y. Is it right? But now I need to change this y in terms of x.
10 minus x squared.
That will be 10 minus x squared. That's right. Is it okay?
Yeah.
Now that's the area of the rectangle in terms of as a function of x. Now let me go on. I will do harder problem in part B. So far, I think that's still on the easy side, not too hard. Number 32. Number 32, a piece of wire 4 meters long is cut into 2 pieces. So I have a piece of wire and it says this is 4 meters long. Now, when they say cut into 2 pieces, they did not say it's cut into 2 equal pieces. Just cut into 2 pieces. So let's say I cut it this way. I cut it here. And let's call this guy here. Let's call this guy here X. Now, if that's x, what will the rest, the length of the rest?
4 minus x.
That's 4 minus x. That's right. Okay.
No,
Then,
we also say x plus 3.
repeat again.
Can we say x plus 3?
X what?
X plus 3.
Why x plus 3?
I don't know. Because we can say like x is 1.
Well,
Okay.
if x is 1, then the other one is 3. But they don't say that it has to be 1, right?
Yeah.
Yeah. So if we can only call that x. If one piece is x, then the other piece must be 4 minus x. Right? Now then, it says each piece is bent into a square. So what happened is this piece here, we bend it into a square. And this piece here, we bend it into a square. Oops, sorry. This piece here, the 4 minus x, I bend it into a square too. This doesn't look like a square. Okay, so this x here, when you bend it to square, what will the side of that square be?
X divided by 4.
X divided by 4. That's right. Because the perimeter should be x, right? So I divide by 4. Now, how about this guy here? What is the side of this rectangle?
4 minus x divided by 4.
4 minus x divided by 4. Great. So you see, when it comes to geometry problem, especially like this, they may actually express that to you, the question, they give you the question just in words, but for us to answer, we need to do a lot of graphing. Okay, now then I go back, then let x be the length of one piece. And the other one, the other piece is 4 minus x. Okay, now when we bend, then it becomes two squares. Square number 1. Square number 1 has the side equals to x over 4, and square number 2 has the side 4 minus x over 4. Now then, express the combined area of two squares in terms of one variable. We already worked in one variable x. So the combined area in terms of one variable is the area of the first one plus the area of the second one. Now, what is the area of this first one? X squared over 16, that's right. That's, maybe I write it this way, x over 4 being squared, that gives me x squared over 16. Plus, what is the area of the second square?
4 minus x over 4.
4 minus x over 4 quantity squared, right? Which will be, the bottom will be 16. How about the top?
16 minus x squared.
No, minus 8x plus x squared. Okay, now then I will add them. They already have LCD, so I can add them. I get 2x squared minus 8x plus 16 over 16, and we can reduce by 2, right? So now the final answer, the area of the sum of two squares will be x squared minus 4x plus 8 over 8. Is it okay? That's our final answer. I use purple. I like purple. Now, that's for number 32. Let me ask you to try number 38. Number 38, I'll give you some idea. You need to sketch the graph though. I mean, again, one thing I don't really like from plenty of students I have in the past, they say that they're a visual learner, but when it comes to word problem, they don't draw anything. I mean, they don't even want to visualize that. Try to visualize that, okay? A line is drawn from origin O to the point P, x, y in the first quadrant on the graph of y equals to 1 over x. So suppose I have the first quadrant and 1 over x. Let's say this is the graph of 1 over x. Okay, now point P is on that graph, and a line is drawn from the origin to that point. From point P, a line is drawn perpendicular to the x-axis, meeting x-axis at D. So I draw a line from here down, oops, why, that's what I said. And we call this point B. This is origin. Now, part A, draw a figure of the situation described. That's basically what we have. Now, express the perimeter OPB as a function of x. So we want to find the perimeter of this triangle. Before I ask you to do this, what is the length here? What is the length here? Maybe, what is the coordinate of B then? What is coordinate of for B? Anybody? The coordinate for B? Okay, well, you need to find out the coordinate for B, okay? And then for that capital B. Now then question B here, to express the perimeter, you need to find the length here. You need to find the length here. And then using these two, you apply Pythagorean Theorem to find the length here. The perimeter of that triangle will be the sum of these three things. Okay, and then part C, express the area of OPB as a function of x. Now let me ask you to do that. How many minutes should I give you? Let me give you maybe 5 minutes for A and for B. Okay, 5 minutes. The coordinate for point B is x, 0. Is it right? Which means the length OB, which is the base, this is equals to x. Now the height is y, but I need to express that as in terms of x, right? So y equals to 1 over x. Now therefore, the perimeter equals to the base x plus the height 1 over x plus the Pythagorean of that, Pythagorean here. Now this will be the square root of x squared plus 1 over x being squared, which is plus square root of x squared plus 1 over x being squared, like that. Okay, now that's the perimeter as a function of as a function of x. Now part B, how about the area of OPB? Now the area of that triangle, the area of the triangle will be 1/2 times the base times the height, which is 1/2 times, what is the base?
X.
X. How about the height?
1 over x.
So when I multiply this, I get 1/2. You see that the area of the triangle will be 1/2. In fact, that's a bit supposed to surprise us a little bit, that this is whatever the x that you choose, the area of that triangle is still 1/2. In other words, I can choose my x to be, let's say, my coordinate p to be here. Okay, my coordinate p to be there, and the area of this triangle here, is still 1/2.
Why?
Huh?
Why, please?
Well, because it's the, you see, the area of the triangle is actually independent of x. You see that? It's independent. It's not depending on how far you choose your p from the origin. You can choose this p here, and the area is still 1/2. See, because this will give you what? Let's say this will give you, the length here is p. Therefore, this guy is 1 over p. The product will be 1 times 1/2, still 1/2. Okay, again, because the formula for the area here is not depending on the x. That's for number 38. Let me ask you to try number 40. Let me ask you to try number 40. Let's make it together with your break. Do you have your book with you?
Yes.
Okay, let me ask you to try number 40, Dave. Number 40, let's say it takes you 5-10 minutes, maybe at most. And then with another 10 minutes break. Right now it's 5:33. We come back at 5, let's say 5:55. We come back at 5:55 and you are done with number 40. Now on this number 40, we have a similar question to number 32, but this time is even more abstract. We have a wire of length L. It's cut into two pieces. And the first piece is bent to square, second into equilateral triangle. Express the combined total area of the square and triangle as a function of x, where x denotes the length of the wire for triangle. So let's say this first part here is x, and we will bend that to be an equilateral triangle. How about the remaining, by the way? What is the length here?
L minus x.
That's L minus x. And we will bend that into a square. We'll bend that into a square. Now, I think we can find the side of this square easily. This L minus x over
4.
Over x.
over 4, I believe. Because that L minus x is the perimeter of this square, right? Now, how about the side of this triangle? What is this?
X over 3.
That's x over 3. So, what is the area of the triangle?
Half base times height.
That's base times height. So the base is 1/2. I mean, it's 1/2 times the base x over 3. But what's the height though? We need to do it again, huh? Okay, let's do it again then. Suppose I have. That's why I prefer it to actually memorize this. For equilateral triangle, see, the bottom here is x over 3 times 1/2. That's x over 6. If I take half of this, half of the base. If I take half of the base, and then I pull the vertical line down. Okay, now then I need to find out what's the height, right? Now, on the other hand, the other side is x over 3. Now the question is, what is this side here?
Oh, I know what it is. 30, 60, 90. So this is
Yes, that's actually going back to that 30, 60, 90 triangle again. Okay,
Yeah.
so if you happen to remember the ratio, you will see that if in a 30, 60 degree triangles, if the shortest is A, let's say, in this case x over 6 is 1, then this side here will be square root of 3 of that. So in this case, this will be x over 6 times square root of 3. Okay, now, so that's the height, x square root of 3 over 6. That gives me x squared square root of 3 over 36. While the area of the rectangle, the square, will be L minus x over 4 quantity squared, which is L squared minus 2LX plus x squared over 16. So, go back to the original question, what is the total area? Total area will be x squared square root of 3 over 36 plus L squared minus 2LX plus x squared over 16.
What is the sorry if you don't mind me asking. What does the part of L being a constant have to do with anything?
Oh, it just gives us the idea that whatever the L later on, we can find the function for the area of the total area of this equilateral triangle and the square. So you can change this L into any other number later on.
Oh, okay.
You know, okay. I would like you to memorize the following formula for equilateral triangle. For equilateral triangle, if the side is x, if the side of this equilateral triangle is x, then the area is equal to x squared, square root of 3 over 4. Okay, try to memorize this because it shows up a lot in our, actually, in a lot of our discussion, at least in this textbook. But it's actually quite a common question that shows up other places. Suggested homework from here will be, on 4.4. I would like you to do a lot of parts from section A, number 1 to number 7, and then 13 to 19. Those are basic ones. And then I would like you to try question number 33. Uh, 39. 42. This is a good one. And 45. It requires some imagination. Number 54. Oh, okay. And number 53 you should try also, but I think that could be very long. I'm not sure though. I'll try to do it later. But let me go over one question. Consider this a special gift for you. Number 54. Number 54. They call that level C, so they consider that quite difficult. The thing is, this question actually shows up quite often, even in SAT. So what it says that we have two concentric circles, means they have the same center. And then we have the radius for the small one is, the small circle is lowercase r. The radius is r. And the radius for the larger circle, is capital R. Now, then they have a chord. Let me use this color, from one point of the larger circle to another point on the larger circle, but tangent to the small circle. So they have a tangent here, perpendicular. Now it says that this guy here is x. This guy here is x. The length is x. The question is, find the area of within the larger circle, but outside the smaller one. In other words, find the area of the, if you want to call this the ring, find the area of the ring. Okay, let's work it out. The area of the ring is equals to the area of the larger circle minus the area of the smaller circle, correct? Make it small enough. Small circle. Okay. Now, what is the area of the large circle?
Sorry, what is the ring?
The ring is the one I shade here. The blue shade.
I thought that's the larger circle.
No, the larger circle including inside. Including inside.
Oh,
Okay. So I mean, if we call that circle, then it's the whole disk, right? No. I call that ring because only the outside. It's outside of the small circle, but inside the larger circle. That's what we call the ring. Now, what is the area of the larger circle?
Two pi the capital R.
2 pi. 2 pi capital R? I don't think so. That's the circumference. Pi capital R
Pi
squared.
Capital R.
Okay, minus the area of the small circle is pi small r squared, which is pi r squared minus r squared. Now the thing is what it has to do with that x. Here's the thing. Now I can move this r here, this radius here, and it becomes perpendicular. While the largest radius, later on you will see, is actually the hypotenuse of that right triangle. Yo, I delete too much. What am I doing?
I think you can go back with Control Z, no?
Yeah, that's what I should do. Thank you. Oh, I'm still missing the circle. No. This one. Now you see what happened then in this right triangle here. Let me shade it. In this right triangle here, this side is R, and this is capital R, right? So maybe if I do it here, the long one is the hypotenuse R, the short one is R, and this is X. So what will X be? X squared plus R squared equals to capital R squared. So X squared equals to capital R squared minus R squared. But that's basically what we have here. So the area of the ring will be pi x squared. Okay, now that's for this section. I'm going to the next section, 4.5, which is actually, in my opinion, on the easier side compared to this 4.4. Should we start?
Yes.
Okay, I go to 4.5. That is maximum minimum problem. Related to quadratic function. Okay, so the emphasis actually is on the relation to quadratic function. Here's the idea. Let fx, a function of x, has the quadratic pattern ax squared plus bx plus c. Then the function reach the maximum value, which is the maximum or the minimum value when x equals to negative b over 2a. Notice that this is actually the axis of symmetry. Remember, axis of symmetry. And on the top of that, if I plug this x into the function, so if I plug f of negative b over 2a, then you will see this is equals to negative d over 4a, where the d is the discriminant. B squared minus 4ac over, no over. Yeah, the d is just that. Now, of course, it will be maximum when the leading coefficient is positive. Actually, no, negative. It will maximum with the leading coefficient is negative. Yeah, because the parabola opens down, right? And it will be minimum when the leading coefficient is positive because the parabola opens up. Now, this x here give us the x component of the vertex. Okay, while the y give us the y component of the vertex. Maybe I write it down. So the vertex actually has this this coordinate negative b over 2a, negative d over 4a. Now let me develop that first. Now, we have learned from the past, we have learned that the axis of symmetry, where the maximum or minimum happen, is x equals to negative b over 2a. Now, I want to show that when I plug this negative b over 2a into the function, I will get negative d over 4a as the result. So f x equals to ax squared plus bx plus c. If I plug that negative b over 2a in, I will get a times negative b over 2a squared plus b times negative b over 2a plus c. That's a times b squared minus 4a squared minus b squared over 2a plus c. Now I multiply that a in, I cancel one of the a on the denominator, I get b squared over 4a minus b squared minus over 2a plus c. Now let me do the LCD. The LCD is 4a. So I will get negative b squared plus 4ac over 4a. If I factor the negative out, I get b squared minus 4ac over 4a. Now, but we have learned that b squared minus 4ac is the discriminant. Okay, now that confirms that the vertex, if we have the maximum minimum on a quadratic function, then the vertex will happen at the axis of symmetry for the x component, and then for the y component is negative d over 4a. Now, together with what we learned earlier in 4.4, we will do maximizing, minimizing problem straight from word problems. Let's say, for example, we take a look on the exercise set. Let's do the easy one first. Number 2. Find two numbers adding to 20 such that the sum of the squares is as small as possible. So let x be one of the number. You can say this x and y, and then x plus y equals to 20. So what is the y?
20 minus x.
20 minus x, that's the other number, right? So the other number is 20 minus x. Now then, we will now find an expression for the sum of their squares. So sum of squares will be the first number being squared plus the second number being squared. Okay, so this is x squared plus 400 minus 40x plus x squared. That's 2x squared minus 40x plus 40, plus 400. Notice that this sum of squares now form a new function on x that gives us the sum of squares. But at the same time, notice that this function is quadratic function. Now, this quadratic function, is it, if you imagine the parabola, is it open up or down?
Up.
It opens up. So does it has maximum or minimum?
Minimum.
It has minimum. And the minimum is? Minimum is when x equals to what?
10.
How do you get that? Negative b over 2a. that's equals to 10. Okay, so if x is 10, what is the other number? So those two numbers are the first number is 10. What is the second number?
So 10.
Also 10. That's 20 minus 10, right? Okay, notice that the question is find the two numbers such that the sum of the squares is the smallest, the minimum. Okay, the question is not find the smallest possible sum of squares.
How did you get the first 10? The x equal to minus 40 by 2 by 2.
Negative b over 2a that I have
Oh,
above.
okay. Yeah. Yeah. Got it. Thank you.
That's what I use. Okay, that's for number 2. So here's the thing. What is new for us? This is what's new. What we did from 4.4, what we did from 4.4 is actually up to here. That's what we did up to 4.4. Okay, now in this 4.5, if the function or the expression we get turns out to be a quadratic, then actually we can go on to maximize, or in this case minimize that. Okay, this is 4.5. This is 4.4.
Julia.
Okay. Now let's continue. That's for number 2. Let's see number 4. No, not number 4. How about number 6?
You went so fast. I'm not finished the.
Then don't get distracted.
Yeah. Just a couple minutes. Thank you.
Okay, let me show you this again.
I'll take. Yeah, thank you.
Okay, let me go on with number 6. Don't worry, later on I will post this note on the discussion board, and once I able to download and upload the lecture video to YouTube, I will give you the link so you can review this again. Okay, number 6. What is the largest possible area for a rectangle with perimeter 80 centimeters? Okay, let me grab a rectangle whose perimeter is 80 centimeters. Now the question is, what is the largest possible area? Well, to find the largest possible area, I need to first find the dimension. Suppose I call this x and this is y. What I want to do is, let me ask you to do this. Can you express the y in terms of x? What is y in terms of x? We know that the perimeter is twice the length, in this case is x, plus twice the width, which is y. Now, I want you to work this out and find what y be in terms of x.
40 minus x.
Of x, that's right, you will see that y equals to 40 minus x. Okay, but you work it out. Now then, the area is equals to x times y, but if I express that into single variable, that will be x times 40 minus x. Is it right? So that's now the area function of x. Now then from here, we want to find the largest possible area. Let's distribute this first. I get 40x minus x squared. Is it quadratic?
Yes.
It's quadratic. And what is the a?
-1.
The b is?
40.
The c is?
0.
0. Now, if I want to find the largest area, am I finding the x or finding the area that is largest?
The area that's largest.
So are we looking at the x or the y of the vertex?
The y.
If we want to find the x that gives us the largest area, that's finding the x component of the vertex. But if what we want here is the largest area for that rectangle, right? So that's the y component of the vertex. So maximum area is negative d over 4a. It's negative of, what is the d? D squared minus 4ac. That's negative of 1600 on the top over negative 4 at the bottom. That's 400. That's the maximum area. Actually, if you don't want to find the maximum area directly, you can find the x that gives us the maximum area. The x that gives us maximum area, that's negative b over 2a. That's negative of 40 over 2 times negative 1, that's 20. But if x equals 20, what is the y? If this x equals to 20, what will the y be?
100.
Huh?
20.
Another 20, right? Another 20.
Okay.
Because the y is 40 minus x, remember? Okay, now then when x and y being multiplied, when you multiply x maximum and y maximum, you get that 400 that we had earlier. So instead of using the maximum area right away, you can find the x where you get the maximum area, then you can find the maximum area. Okay, that's for number 6. How about number 8? Let me ask you to set it up first. While some of you I know still writing on these. Okay, I can let you write that. But take a look on number 8. Once you're done writing this down, you see number 8. I have a rectangle whose perimeter is 12. Suppose this is x. What is this? the same routine we did earlier. The y will be 6 minus x. Okay, because the perimeter is 12, right? The perimeter of that rectangle is 12. And what we want to find out is what is the shortest distance possible for any rectangle with perimeter 12. Of those many rectangles of perimeter 12, what is the shortest possible diagonal? Let's call this D here. Then the D squared equals to x squared plus 6 minus x being squared. X squared plus 36 minus 12x plus x squared. That's 2x squared minus 12x plus 36, such that the distance is the square root of that number, that expression. Now, maybe if you are writing this down, let me ask you to write that far at least. Yes, we don't have the, we don't know how to deal with radical functions. I mean, we don't know how to make it maximum or minimum yet. Okay, we cannot make it maximum minimum yet, but we know one thing. We know one thing, that this D here will reach the maximum, or in this case will be the minimum, when 2x squared minus 12x plus 36 is maximum or minimum. Okay, so in other words, to minimize this D is the same to minimize D squared. Okay, so instead of dealing with D with the square root, we just deal with the radicand, the guy inside the house. Just deal with the radicand, the guy inside the house. Now, is the parabola inside the house opens up or down?
Up.
It opens up. So as we expect, that should give us the minimum, right? Okay, so D is minimum when D squared is minimum, 2x squared minus 12x plus 36 is minimum. And that happened when x equals to 1. When x equals to negative of b over 2a. Is it right? So that's when x equals to 3. Now when x equals to 3, let's call that the width. How about the wide? Use this. Now, when you actually do the problems on your own later on, please don't skip steps. Okay, I know some of you can do math quite fast without writing everything down. But at the same time, sometimes we get stuck because we don't see what relation between x and y in this case. Now, you didn't see it not because you didn't really see it. It's just because you didn't write it down. Okay, so the simple work of writing down some simple expression, please do it. Okay, stop thinking this way because it's easy, then I don't need to write it down. No, because when it is hard, you don't know what to write anyway. Okay, so when it is easy, write it down. When it is hard, it takes more time to write down. Okay, don't make it in the situation when it is easy, you don't write down. When it is hard, you don't know what to write. Either way, you don't write anything. Okay, that's a wrong approach. Okay, now what is the y here? There will be 6 minus x, 6 minus 3, which is 3. So the dimension to get the shortest diagonal is, the width is 3, the length is also 3. Okay, that's for number 8. Now I have approximately 20 minutes left. Let me give you 1 minute to copy this down. And I would like to go over 2 more questions from here. Okay, let me continue. Next one, number 12. Find the point on the curve y equals to square root of x nearest to the point 3, 0. Let me try to sketch that. So, oops. No, not this one. I want this one. And then I have y equals to square root of x. And I have point 3, 0. Let's say it's here. This is 3, 0. Or what we need to do is to find the point, find the coordinate p, x, y, such that the distance to 3, 0 is the shortest. Let's use this one. I need to minimize this d. Now, what we will do now is to find what function is d in terms of x. Now, suppose we have p coordinate x, y. Then what is the distance from p to 3, 0? The distance from p to 3, 0 is x minus 3 squared plus y minus 0 squared. Now write it down first. I hope you remember that distance formula. So this d is equals to square root of x minus 3 squared plus y squared. But what is y squared?
Square root of x.
Being squared. Right? Yes. Y is square root of x, but you square that. Correct? So now we get square root of x squared minus 6x plus 9 plus x. Then d is square root of x squared minus 5x plus 9. But the d is minimum when the radicand is minimum. So we don't want to deal with the square root. We deal with the radicand, the guy inside the square root. And that is minimum when x equals to what? Negative b over 2a. That's 2.5. Now then, so I get the x of this p already. I get the x of this p already. Now how to get the y?
Plug in x.
Yeah, that's right. So coordinate p will be 2.5, comma, the y is square root of 2.5. Okay, now this point P is the point on the curve that is closest to 3, 0. Now, you will see that question number 14 is actually very similar. Question number 14 will be very similar to this. Oops. The difference is it changed the square root of x becomes a line. However, if you think about number 14, we did that kind of problem already in class using another method. Okay, but this time you can use this method. You set up the distance function and then minimize the radicand. Okay, go on further. Number 18. You may think this question is harder, but this is actually on the easy side. Number 18, we have function a is equal to 3x squared plus 4x minus 5, while the b is x squared minus 4x minus 1. And the question is, find the minimum of a minus b. Now, I'll give you a hint. Find what is a minus b first. If you subtract this, what will a minus b be?
Oh.
Hmm? So what is a minus b?
2x squared
Uh-huh.
plus 5x.
Plus 5x.
A minus b.
Yeah, a minus
plus
b.
8x. Sorry.
Plus 8x
Plus
and then
8x.
X minus 4.
minus 4. That's right. Okay. Now then, when they say find the minimum of this, do they want the x value or the y value?
The y value, I think.
They want the y value. That's right, they want the y value. So the minimum is therefore equals to negative d over 4a. Can you compute that? Okay, so what is the d?
What is what?
What is the d here? The delta d. That's d squared minus 4ac over 4a. That's 64 plus 32 over 8. Am I right? Yes, so that's negative of 8 plus 4, negative 12. So the minimum value of this parabola is negative 12. I mean, whatever x you plug in, the smallest value of a minus b you can get is negative 12. Okay. Now I think I will stop here. Your suggested homework from this section will be for this 4.5 will
I
be,
just mix. Is it d equal? Oh, is it you use the formula b minus 4ac?
b squared minus 4ac.
Oh yeah, b squared minus 4ac.
Mm-hmm.
And you sub. Oh, okay.
Sorry, I have a question.
Uh-huh.
Yeah.
So I couldn't have used negative b over 2a to get.
If you use negative b over 2a, you will get the x that make it the minimum,
The x must.
Oh,
right?
okay.
That's okay if you do it that way. Let's see.
Yeah.
So the x minimum will be negative b over 2a, right? So
Yeah.
that would be negative 2.
Yeah.
Okay. So a minus b minimum, when you plug in x equals to negative 2, that's 8 minus 16 minus 4, that's negative 12.
Oh, okay.
Okay, so it's okay if you use negative b over 2a, but that gives you the x for a minus b to reach the minimum, but that's not the minimum itself. You see?
Yeah.
Okay. Now your suggested homework from this section is 4.5, number 1 to number 21. Try to do as much as you can between today and Tuesday. Now, you remember in my last discussion or announcement, I have some lectures videos that I want you to watch from YouTube?
Yes.
Look at my previous announcement. I think I put it in my announcement. Let me see. What's that? I think I put it in the announcement. Here, on the 31st, 2 days ago, I believe I asked you to watch this. Okay, this lecture video. So what you will do, you will copy the link, you copy that, and then go to. Are you with me?
Yeah.
Right? Okay.
Yes.
Now, you can skip this composition of function or domain for now because that's something we did already before. But on Monday when we do 4.6, well, on Monday when we do 4.6, it has a lot to do with what I asked you to watch here. Don't worry about this 3.1. Don't worry about this 3.1 because I copy paste this from my Santa Monica Precalculus class. The thing is, right after we are done with 4.6, right after we are done with 4.6, we will jump to chapter 12. So what I did here is to prepare you actually not only for 4.6, but also chapter 12. Okay, the one that you really need to know is especially this introduction to graphing polynomial. Each one of these lecture videos is not long. I think it's at most like 10 minutes. That's the at most. And a lot of them actually repeated ideas. Okay, but even though they are repeated, they're important. Now, I want you to watch them first such that on Tuesday when we come back, I will still go over this, but I don't want to go over this like too much detail anymore. Yes, it will be fast if I don't give you this lecture video now. So to help you absorbing the material on Tuesday faster, watch this first, okay? Then basically on Tuesday next week, I will finish 4.6 together with chapter 12, okay? It seems like I jump a lot, but chapter 12 actually digging a lot further into this 4.6. And I know a lot of instructors, I know at least 2 instructors at West LA College actually skip chapter 12 in the entirety. But at the same time, I think you need that chapter 12, how to deal with polynomial better when you go to Calculus 1, okay? And then after Tuesday, I will also post some lecture videos to prepare you for 4.7, rational functions, okay? Then after that, we can go to chapter 5. So hopefully next week on Thursday, we already do chapter 5. By the way, next week's supposed to be our spring break, right?
Yeah.
But we already have our spring break.
Yeah, they move it.
Yeah, so please don't tell me, Thomas, according to schedule of classes, that spring break. No, they already moved it. Okay, so please study. And don't forget you are in Precalculus, you are going to Calculus. So work harder. Okay?
Okay.
Okay, see you then on Tuesday.
And for attendance, we just reply on the discussion.
Yeah, just reply on the discussion, say I'm
Okay.
here. Yeah. Mm-hmm.
Thank you.
I don't
Bye.
really worry about that. I just don't want when they audit us and then suddenly, oh, you didn't take attendance, you know.
Oh, okay.
Yeah. Okay.